Hi, welcome to my video on writing algebraic expressions for two unknowns. In this video, I'm going to explain how to write the expressions for two unknowns. One number is twice another number. We let x be one number, and it says the other is twice that. Okay, so we let 2x be the other number. So notice now I'm deciding in each problem which one is going to be the x and what the expression is for the other one. In most cases, what I do is what's on the right I let be x, and what's on the left, then it's going to be in terms of that. Larger number is 8 more than the smaller. The smaller is on the, what's on the right, I let be x, and the other one is in relation to that. So let x be the smaller number. And the larger is 8 more than the smaller, so it's x plus 8 more than z. Again, what's on the right, I let be x. The second number is 9 less than the first number. So the first number is on the right, so that's x. So I let x be the first number. Again, I use the number symbol. The second number is 9 less than the first. So 9 less the first. 9 less the first. Be the second number. D, the length of a rectangle is triple the width plus 5. Again, width is on the right, so let W be the width. When I deal with length and width, I like to use W and L. So let W be the width of the rectangle. And it says the length is triple the width plus 5. So triple the width plus 5 be the length of the rectangle. The son's age is the father's age less 30. So we could let x be the father's age. Again, father's on the right. So if I let x be that age, then the son is 30 less than that. So you let x minus 30 be the son's age. Now, some people will do that the way I'm saying, but you can, if you wish, let x be the son's age. Just try this one. So if x is the son's age and the son is 30 years younger, that means the father must be older by 30 years. If you were doing a word problem on this, it would make no difference which way you go. It would still get, in this one, when you solve for x, you get the father's age. If you did it this way, when you get x, you have the son's age, but it still works out. F, the cost of n apples, excuse me, if one apple costs 40 cents, so it's 40 times n is the expression for the cost of n apples at 40 cents an apple. You multiply. The number of cents, G, the number of cents if there are 6 more dimes than nickels. Now what I'm going to do this time, I'm going to draw a little box. Sometimes when you do it this way, it works out much neater. Let me show you. Here's the box, and I have 3 columns. We got 1, here they are. So I'm going to mark in the first one here as coin. So we have nickels and dimes. So there are 6 more dimes than nickels. So let's start off with N for nickels and D for dimes. Now we have the number of each. I'm going to put number symbol, the number of each. Well, it says, again, nickels is on the right, so I'm going to let nickels be n. And the number of dimes is 6 more than the number of nickels. So the number of dimes is n plus 6. So now we're going to do the value in cents. So just put that value. So the value of n nickels is 5 times n. And the value of dimes is 10 times n plus 6. So doing it in this box form works out very nice. Now we want the number of cents in all of these. So that's 5n, add on 10 times n plus 6. The number of cents in all of it. So that's 5n. 10 times n is 10n. 10 times 6 is 60. When we add up, we can only add the like terms 5n and 10n, which is 15n. And 60 goes by itself because it's not a like term. So 15n plus 60 is the number of cents in this expression. H, the sum of two numbers is 40. So what I do is I let x be one number. If the sum is 40, then the other number is 40 minus x. Again, one number is x, the other one is 40 minus x. If you add those two together, again, x, add on 40 minus x, the x's cancel, and you get 40. So the sum, you always subtract the total from one of the numbers. Let's continue. Two angles are complementary. If two angles are complementary, let x be the measure of one angle. Then we let, complementary means add up to 90, 90 minus x be its complement, the measure of the complement, that is. Two integers are consecutive. Well, we know what consecutive means right after each other. So sometimes we forget. So I go 6, 7, and 8. So if you notice there's a 1 difference here, and right here there's a 2 difference. So if I let n be the first consecutive integer, then the next one is you add 1. Notice 7 is 1 is 7 is 6 plus 1. 8 is 6 plus 2 if you keep on going. So let n plus 1 be the second consecutive integer. I'm using ditto marks to repeat. K, two integer consecutive odd. Be careful with consecutive odd. Let's go with a 9, 11, and 13. So notice right here there's a 2 difference, and right here there's a 4 difference. So if you let n be the first consecutive odd integer, then the next one, notice you have to add 2. Be careful. By writing down some numbers, you see that you got to add 2 and 4 and 6. Consecutive, you add 1, 2, and 3. L. What I omitted here. You see the blank. I just wrote down the father's age is twice his son's age. So the son's age is on the right. So I let x be the son's age. The father's age is twice his son's age. So you let 2x be the father's age. Again, in the sentence, what's on the right is I always let be x, but you don't have to. Two integers are consecutive even. So if you take, let's say, a 6 and 8 consecutive even, So they're consecutive, they follow each other, and they're even. Notice, again, there's a 2 here, and there's a 4 here. So 8 is 6 plus 2. 10 is 6 plus 4. So we let n be the first consecutive even integer. And notice the pattern. You're adding 2, so the next one is n plus 2. Be the second consecutive even integer. And notice, again, the two patterns for consecutive odd and consecutive even, the patterns are the same, except when you do this one, n is the first consecutive odd, and here, n is the first consecutive even. So if you start with an even and go to an even, you add 2. If you start with an odd and go to the next odd, you add 2. n, the sum of two numbers. Find the sum of two numbers. The larger number is triple the smaller. So let's let the smaller numbers on the right, so let's let n be the smaller. So let n be the smaller number. So we let the larger numbers triple the smaller, so it's 3n be the larger number. The sum of the two numbers. So your sum means you're going to add them together. So the sum is n, add on 3n. So the sum of the two numbers, that's a 1. 1 plus 3 is 4. You can add like terms. Oh, two adjacent angles form a straight angle. So if two adjacent angles form a straight angle, there it is. There's two adjacent angles. There's a straight angle and a straight angle. So that means if you let x be the measure of one angle, one of the angles, and because that one is x, then this one right here must be 180 minus x, because the two of them together add up, be the measure of the other angle. Let me rub that S out there. So similar to supplementary, they add up to 180. P, the speed of a plane A, is 100 kilometers an hour faster than the speed of plane B. If both flew for 3 hours, find the total distance traveled. Well, this one also can be done in the form of a box. You get used to these when you do some word problems on distance and age. And so what we have is, let's see what we have. Okay, so we have, first column we have is the planes. We have two planes, and it says, notice, I'm going to let the plane A is in terms of B, so I'm going to do B and then A, because I let the rate, so this is the rate I'm going to denote by R. So the rate of plane B is R, and plane A is 100 kilometers faster, so this is R plus 100. And the time, they both flew 3 hours, and that gives us, let's look at the distance. So distance, we'll put it here, distance equals rate times time, or time times rate. So if we take the time and multiply by the rate, we get 3r. If we take the 3 hours and multiply by r plus 100, we get 3 times r plus 100. So this is distance, and this distance is in kilometers. So the total distance by both of them, the total is, you have to add them up. So it's a 3r, add on 3 times r plus 100. So that's 3r, add on 3r plus 300. Add like terms, 6r plus 300. And again, that distance is in kilometers. The table works it out pretty good. Planes, rate, the time, and the distance. And then you want the total, you add them up. Let's continue. The length of a rectangle is 6 more than twice its width. Write a simplified expression for its parameter. Okay, again, the width is on the, so we're going to let W be the width, because the width is on the right. The length is 6 more than twice the width. So 6 more is add twice the width, so it's twice the width plus 6 be the length. And what happens, there is a formula that perimeter is twice the length plus twice the width. Because if you think about a rectangle, if you think about the length is 2w plus 6, this one up top is 2w plus 6, the width is w and the width is w. You got 2 of each. So if you write, you can add all these up if you wish, or you can put 2w plus 2l plus 2w. So the length is 2w plus 6. The width is just w. And if you work this out, 2 times 2w is 4w, 2 times 6 is 12, plus 2w. If you add like terms, I'm just going to group them together. W's go together, so you get 6w plus 12. You could just add those right here in this step and say 2w, 4w and 2w, 6w plus 12, without writing this if you wish. R, the complement of an angle plus 110. The complement of an angle, we'll let x be the measure of an angle. A complement, we'll let 90 minus x be its complement. So we want this, what is the complement plus 100? So the complement is 90 minus x plus 110. That's 110. I just said 100, but it's 110. And we put this in order, so that's negative w, negative x plus 90 degrees plus 110 degrees, so that's negative x plus 200 degrees. Complement plus 110. S, the measure of an angle, subtract its complement. So we're going to let x be the measure of an angle. That should be an N because of the A. Then we're talking about the supplements. So we want to let 180 minus x be its supplement. Okay, now the measure of an angle, well, as x, subtract its supplement, 180 minus x. Notice the subtraction sign, and I got to put a bracket around this binomial, because if I don't, it's going to be wrong. So because I'm subtracting, I can put a 1 there, so that's an x. Negative 1 times 180, negative 108, negative 1 times negative x is positive x. And the x's are like terms, so we group them together. So that's a 2x minus 180 degrees. The measure of his angle, subtract his supplement. There it is, simplified. And T, the sum of two numbers is 12. Write a simplified expression for the sum of twice the smaller plus the larger. There's two different expressions, but the expressions come out to be the same. Let me explain. I'm going to draw a line down here to what I'm going to do. The sum of two numbers is 12. So what I'm going to do is let n be the small number the sum of the two numbers is 12. So that means that the other number must be 12 minus n. Based on the first sentence, because the two numbers add up to 12, one is n, the other one is 12 minus n. But I indicated that's a small number and that's the large. Now we'll go at the next sentence. Find the sum of twice the smaller plus the larger. So twice the smaller is 2 times the smaller plus the larger. So there's twice the smaller plus the larger. And that's 2 times n is 2n plus 12 minus n. So that's 2n minus n plus 12. So that gives you n plus 12. So that would be the expression for the sum of twice the smaller and the larger. But you can also, you have a choice. You could also say, let n be the larger number. So n is the larger because you have a choice. Then you could say that 12 minus n be the smaller. You can see that smaller is n, 12 minus n is the larger. If n is the larger, then 12 minus n is the smaller. Same expressions, but n is the larger in this one. So now let's read. It says the sum of twice the smaller. So twice the smaller is 12 minus n plus the larger, and the larger is n. So if we multiply 2 by that, you get 24 minus 2n. 2 times 12, 2 times negative n, plus n. So that's negative 2n plus n plus 24. So that's negative n plus 24. So the two expressions will represent this either way, but let me explain a little tiny bit further. What about if you picked two numbers? Let's pick two numbers. And I'm going to put the two numbers in here. Let's say we picked a 5 and a 7. 5 and 7 add up to 12. So in this case, n was a smaller number. So in this case, what I'm talking about as an example, n is 5, because n is the smallest number. That means the larger number is 12 minus 5, which is 7. Makes sense? But this expression says it's 5 plus 12, because n is the smaller. So that expression is representing the number 17 in this case. If I took two more numbers like 10 and 2, then it would be different. So if 5 is the smaller number and 7 is the larger, over here we're saying n is the larger. So that means over here we're saying that n is 7. So between these two numbers, n is smaller, so I have to pick the 5 in this expression. Between the two numbers, I'm picking the 7 because I'm saying n is larger. So that's the larger number, add on 24. And negative 7 plus 24. N is the larger, negative 7 plus 24, 17. So the two expressions, even though they look different, end up with the same number if you use 5 and 7. It's your choice. But either one of these will work if you're doing a word problem. You wouldn't have to do both of them. Just explain. If you like my video, click the like button. Click the subscribe button if you're not a subscriber, and the notification bell. Write a comment on my video if you wish. I visit my math website, mathfullyexplained.com. I have 3 sections, one on me, my degrees and teaching experience. The other section is on videos. The other section on videos talks about how I'm going to help you learn your math, some of the ideas and tricks I'm going to teach you. And the content talks about the topics and the number of videos on each topic. Black font is what's online right now, and the red font will be what's there in the near future. Thank you very much for viewing my video. Bye-bye.